Today's lesson is on the midpoint formula and the distance formula in finding lengths of segments using midpoints and segment bisectors. The midpoint of a segment is the point that divides a segment into two congruent segments. M is the midpoint of segment AB, so that AM is congruent to MB and AM equals the length of MB. A segment bisector is a point, ray, line segment, or a plane that intersects a segment at its midpoint. A midpoint or a segment bisector, we say, bisects the segment. Line CD is a segment bisector of AB in this example. Therefore, AM is congruent to segment MB, or the length of AM equals the length of MB. Let's look at some examples. Example 1. In the figure, PM is equal to 1.8 millimeters. Identify the segment bisector of segment PQ and then find the length of segment PQ. The segment bisector would be ray MT, and the length from P to Q, if P to M is 1.8, then the length from M to Q is 1.8. If we add them together, 1.8 plus 1.8 is 3.6 millimeters. Next example, point M is the midpoint of segment AB. Find the length of segment AB. If these are congruent segments, what's marked on the picture, AM is congruent to MB, then 3x minus 4 should equal 2x plus 1. We'll solve for x. I'm going to subtract 2x to the left. 3x minus 2x is 1x minus 4 equals, bring down the 1. Add 4 to both sides. X equals 5. If x is 5, we go back up to the beginning. We want to find the length of the whole segment. So from A to M is 3 times 5 minus 4. 3 times 5 is 15 minus 4 equals 11. From M to B is 2 times 5 plus 1. M to B is 11. They should be the same, so A to B, the whole length would be 11 plus 11, 22. Midpoint formula. The coordinates in two-dimension now we're looking at of a midpoint of a segment are the averages of the x-coordinates and the y-coordinates of the endpoints. If I have a point A at x1, y1 and B is at x2, y2, there are points in a coordinate plane, then the midpoint M is going to have coordinates of x1 plus x2 divided by 2, y1 plus y2 divided by 2. Example, the endpoints of AB are negative 8, 7, and 5, 1. Find the coordinates of the midpoint M. So my endpoint, this is going to be the first x and y. We'll call this the second x and y. So my midpoint for x, M will stand for midpoint. We add the x's, divide by 2. So negative 8 plus 5 is negative 3 over 2. Y midpoint, we add the y's. 7 plus 1 divided by 2. 7 plus 1 is 8 over 2, which is 4. So my midpoint is at -3/2, 4. The next example, we're given the midpoint, so this is the xm and ym. We'll call this x point our first one, x1, y1. Find the other end point. So I'm going to plug in xm into my equation is 2. The first x is 4. We're going to find the second x divided by 2. We're going to do the same for the y's. The midpoint is 3 equals 1 plus y. 2, we're finding the second one, divided by 2. Now I want to get rid of the fractions, so I'm going to multiply both sides by 2. 2 times 2 is 4, equals 4 plus what number? Subtract 4. My number is 0. 4 minus 4 is 0. Then over here, if I multiply again both sides by 2, 2's cancel on the right. -6 equals -1 plus what number? Add 1. y2 equals -5. So my other end point is going to be at 0, -5. And that's point Q. Oh, fixing, I see an error here. This should be a +1, but not a -1, so we're going to subtract 1. So it'll be -7. Next we have the distance formula. Distance formula is really just a version of the Pythagorean theorem. We can solve problems like that. x2 minus x1 is like our A. y2 minus y1 is like our B. Notice we're squaring it. And then this was like our C, the hypotenuse. So we learned a squared plus b squared equals c squared. So c is the square root of that. Where this is the x2 minus x1, the a, b is the y2 minus y1. You can look at it either way. Here's an example. Your school is 4 miles east and 1 mile south of your apartment. A recycling center where your class is going on a field trip is 2 miles east and 3 miles north. Estimate the distance between the recycling center and your school. So we're starting at a school is 4 miles east and 1 mile south of your apartment. The recycling center is 2 miles east so 2 miles east and 3 miles north of your apartment. Now here's the recycling center. The distance between the recycling center and your school Here's the school down here. Okay, remember this whole distance was 4. This is 1. This is a 2, and this is a 3 up here. So if we take a look at our picture, we have the distance here is length 1, so let's find the distance here, which is like the hypotenuse. So this again was distance of 3. I'm going to move the 3 over so we're not confused. And this is 2. So I'm going to say 2 squared plus 3 squared equals this hypotenuse h squared. 4 plus 9 is 13. So h is the square root of 13. Plus the 1. So square root of 13 plus 1. A park is 3 miles east and 4 miles south of the apartment. Find the distance between the park and your school. So a park is 3 miles to the east. So again, here's our apartment. 3 miles east and 4 miles south. So then 3 squared plus 4 squared equals, we'll call this the hypotenuse squared. 9 plus 16 is 25. So h is the square root of 25, which is 5. Now we'll just do a straightforward distance formula example. Call the first one x1, y1. Call the second one x2, y2. We'll use distance for this one. x2 minus x1 squared. That's like our A. y2 minus y1 squared, like our B. In the Pythagorean theorem example we just did. I'm going to plug the numbers in. 7 minus 1 squared plus negative 9 minus 3 squared. 7 minus 1 is 6. Negative 9 minus 3 is negative 12. And you can leave it in square root form or find a decimal if you like. 36 plus 144. Which would be the square root of 180. And again, you can write this as a decimal if you want. And that's it for our notes for today.